Thanks, Daniel. So I'm going to try to keep my voice going. It's getting a little, got a little thing in the back of my throat, so if I get a little quiet and you can't hear me, just raise your hand. I also have a tendency to speak fast as I start to get excited about things. So if I start to speak a little fast, just raise your hand differently and wave at me, and I'll slow down a bit. So thank you again for the welcome, Daniel. I'm going to try not to mention the word PBX too much so that Ule doesn't come up here and hit me. But that's good, because we're actually talking about using Asterisk as something other than a PBX, as a media application server. All right, so for the most part, when we talk about Asterisk, it as a PBX or as a conferencing server or as a something managing queues in a call center, we typically think of it like that, and clearly Asterisk as a PBX is how we generally envision it. So the goal of this talk is, can we make it more generic? Can we make it a generic media application server such that we can make it do whatever we want as opposed to one particular thing? And this is the reason to do that. When you have a relatively small site, certainly if you're just using Asterisk in single appliances, or you only need 2 or 4 instances of Asterisk, this is not as interesting of a topic. It's academically interesting. When you get to a certain size, much like the SIPGate guys, this suddenly becomes much more interesting, because we're not talking about 2 instances of Asterisk or 4 instances of Asterisk. We're on the scale of hundreds of instances of Asterisk. And so suddenly, treating things as a generic media application server is much more interesting. But first, I'm going to look at why this is something of a problem for traditional deployments of Asterisk. So, for the most part, I'm going to be assuming that we're going to front-end Asterisk with Kamailio, because that's a very smart thing to be doing. So Kamailio is going to handle a lot of our SIP switching for us. It's going to act as the registrar. It's going to provide location services for the Asterisk instances. So hopefully we can already assume that we've pulled a lot of that SIP stuff out of each individual Asterisk instance, so they're a little bit dumber, and Kamailio is handling some of that smart SIP stuff for us. But we'll start off by just trying to use traditional Asterisk dial plan and see how far that gets us. So first of all, let's assume that we're going to try to make every Asterisk server the same. This is in all points in time, there's going to be a lot of hand-waving as I operated a very, 100,000-foot view, like dropping all sorts of things out of it. So let's say I've got a cluster of Kamailio instances, at least 2, because that's a good idea. And I've got 3 Asterisk servers, maybe more, sitting out behind there. And I'll just use the dispatcher module in Kamailio and do some very simple round-robin routing, or maybe use some of the performance routing such that I'm distributing my calls across my servers in an intelligent fashion. If I'm doing that, and I'm multi-tenant, and I've got multiple customers on my platform, all my Asterisk systems are probably going to share their configuration, because I can't predict necessarily where Kamailio is going to send a particular customer's call onto which Asterisk instance. That's a problem. Because when you're sharing configuration between Asterisk instances, now you can no longer easily scale it. All systems have to know all the same information, which means that anytime I have to update any customer's information on an Asterisk instance, I have to go touch all my Asterisk instances, and more downtime, more maintenance, all the other kinds of things. One way of working around this is to use FuncoDBC in Asterisk, and you can do some very careful dial plan construction with it. So if I'm very naive and I'm doing some very terrible dial plan writing where I've got 2 conferences, one for customer 1 and one for customer 2, and they've got their own contexts in the dial plan so that they're logically segmented out, but this customer has their own user profile and this customer has their own user profile that's been configured, and so I've had to separate them out. I can be a little bit smarter with that with FuncoDBC, and I can coalesce all those applications down into one single context, and then do a database lookup based on something about the call that came in. I picked caller ID here. That's probably a terrible idea, but you can use something to go query down the database to actually get the user profile for that particular customer. And that's nice. That makes my problem a little bit less bad. So maybe I've done some very good dial plan configuration here, and I'm using FuncoDBC now to pull that information out. So my Asterisk instances are a little bit easier to manipulate and control. So let's say Alice tries to dial into her conference, and so she dials 1,000, and Kamailio detects that top Asterisk PBX has the least load, so it routes the call over there. And then Bob calls in, and Bob works with Alice, and Bob also calls. Well, there's already a call on that top Asterisk PBX, so Kamailio does the right thing and sends it to an Asterisk PBX that doesn't have a call on it. And now we have a problem, because Alice and Bob are on 2 different servers, and they're supposed to be talking to each other. They're supposed to be in the exact same conference. So that doesn't work very well. Yeah. So even with FuncoDBC, some things don't scale very well, because if we're going to route calls effectively to the right instance of Asterisk, you want some of that application logic. You need to know where those calls are and when they have to be logically grouped together by customer, by application purpose. And that doesn't work very well. So option 1's clearly got some issues. So option 2, well, I need a conference server then, right? So if I've got a PBX, most of that's just going to be 2-party calls. It's not as important about whether I've got all my customers grouped on one versus another. Maybe I do that, maybe I don't. But I could actually have some special purpose Asterisk servers, and then I can route all my conferencing to that conferencing server. So now it's a little bit better. And Kamailio is still doing its thing, but now maybe it has groups of servers, and it understands that if somebody tries to reach a conferencing server, it needs to send it off to the conferencing server as opposed to the PBX servers. And that works pretty well, because now Alice and Bob, when they call in, both end up on the same server, and life is grand, until I need another conferencing server. And now I've got the same problem again, where my calls may not end up on the right server at the right time, and I have to do some special things in order to try to get the media together. So yeah, it doesn't work very well either. So having the granularity of functional systems only partially mitigates this problem. We still, at times, want application logic to have some impact on the routing. The problem is we don't know what we want until after it's already been routed by Kamailio. What's more, that's really not what you want Kamailio to be doing. Application logic is not Kamailio's job. It's going to slow it down, and that's not what we want. We want it to process tens of thousands of SIP calls. And so trying to put this stuff at that layer isn't going to make our life any better. At the same time, in an ideal situation, every instance of Asterisk is still generic, and we don't have special purpose Asterisk instances doing special purpose things and then trying to move the calls around based on where things end up. Even in almost any scenario, we might have to do a little bit of that, but we'd like to keep Asterisk as simple as possible. So going back to the goal, can we make Asterisk a generic media application server? Step 1, typically in doing this, after you've pulled some SIP things out and let Kamailio handle those, is try to remove the application logic from Asterisk. And that's kind of a scary thing to say, because that's typically how Asterisk systems gets deployed, is lots of dial plan, AGIs, and a bunch of other things in order to go put all of the application logic into Asterisk. So in Asterisk 13, one of the many things, really in Asterisk 12, but 13 being the long-term support release of Asterisk, there's a new API called ARI, the Asterisk REST interface, and it's an API for building custom communications applications. How many have heard of the API or know what it does? That's great. That's better than it was last year. So slowly but surely the word is getting out. That's great. Okay, but it's good that some people didn't raise their hands, so these next slides actually mean something. A very quick overview of what ARI is. It's a RESTful API. We like to joke that we're pragmatic, not dogmatic when it comes to the definition of REST. We're at level 2, not level 3. So we're close to being, there's some things in there that if you're a true proponent of REST, you might get a little nauseous if you look at the API, but it's close. So it exposes the raw Asterisk primitives as resources. When I say raw Asterisk primitives, I don't mean just channels. It's kind of everything. So anything that if you were a C developer, you would use to go build a dial plan application, that thing typically has a REST resource available for it, and you can manipulate it using RESTful calls. So I can make a post to a channels resource and answer it. I can delete a bridge, and bridges are an object, and so they're their own thing that can be manipulated. I can change a device state to change a BLF on a phone, and I've got a nice little REST API that does all that. Unfortunately, we live in an asynchronous world, and so as much as REST is wonderful, things change in Asterisk without you actually issuing an HTTP request asking them to do so. That means that we have to have some events coming back. And so the API has a WebSocket that you connect and it will spill back events about things happening in your application as JSON. Yay, structured data. If you've ever had to parse AMI, well, sorry, but yay, JSON. Tying all of this stuff together, there's usually just a tiny amount of dial plan that's necessary. And as I said, the purpose of ARI is to allow anybody to go build their own dial plan application. And so the dial plan still has a tiny role here where you have to hand the channel over to the external application controlling it. We do that through a special dial plan application called Stasis. It's a very long story why it's called Stasis as opposed to something straightforward like ARI. This is sometimes what happens. Naming things is hard. But your app is the name of the application that your WebSocket registers and says, I'm servicing the events for your app. And says, OK, that's your app, and I'll start sending you events for what's going on in the channels inside this application. So if you can divide Asterisk now into two separate worlds, very much. You have Asterisk with its traditional dial plan execution, where the traditional dial plan applications live, and that's very much segmented and controlled by the app running Asterisk process. When the Stasis dial plan application gets a channel, it hands that control of that channel over to the external control, to your ARI application. At which point, Asterisk throws its hands up and says, you own it, you own the resources, and it just lets you do whatever you want with those things. And Stasis is the sort of little bridge between those two worlds. This is why it's cool. This is a conference bridge on one slide, written in Python. And I could fit it all in one slide, which I was pretty happy with. This is using ARI Pi. There's some other really great libraries out there that the community's written. I'd highly take a look at Nir's ARI PHP library as well. He's done some fantastic work with that. Lens from Qmetrics wrote a Java library. There's a lot of great libraries already for ARI written in a variety of languages. We're going to connect back to an Asterisk instance that actually establishes the HTTP connection, says, OK, this is we're going to get a token back for that at that point for all the rest of the requests that we're going to make. Really?
HTTP colon.
Oh, yes, you did spot a typo. That should have an S there. Thank you, Uli. We're going to register it for an event. Stasis start is what happens when a channel enters into the application. That's the event that signifies that a channel has entered into your dial plan application and has been handed over to it. And then we just tell our application to run. We're running Awesome Conference. Now here's what's kind of cool. So when a channel enters in, it's going to get called this callback. We're going to answer the channel. You're going to notice that we're going to actually play media directly to the bridge. So bridges are objects. And you can manipulate them as first-class citizens using the API. And so this will play a beep to everybody else in the bridge who's hanging out in there that a new channel is about to enter in, and then we just add the channel to the bridge. And that's it. That's a conference. And the bridge is smart enough to change its mixing type based on the number of participants. So if you start off with one participant, it will use a mixing technology that's appropriate for that. When you go to two participants, we'll use a mixing technology that's appropriate for two participants. And when you finally get three people in there, it'll say, I've got to mix the media. And so it'll switch to a conference mixing technology. And just does it all automatically under the hood. So when we talk about ARI being an API for building custom communications applications, one way of looking at that is that we're talking about building the thing that the dial plan typically is. And if the dial plan is the application logic in Asterisk, then ARI provides us a mechanism to pull the application logic outside of Asterisk. So let's look at a non-traditional deployment. If anybody was to AstraCon and witnessed the aftermath of the AstraDevCon, this would be funny for you. But so we're not going to actually deprecate the dial plan or anything. But so step one is remove the dial plan. Uli knows. I'll get flamed all over the internet for putting that there. That's worth it. So you still need a little bit of dial plan, but I'm just going to throw all my calls in there. Everything that comes in on the server, I'm just going to throw into Stasis and say, my external application, you control it. And so now this same dial plan exists on all my servers, and I don't have to update them when I add a new customer or do anything else like that. ARI by itself does not provide you the ability to manipulate multiple servers, and that's okay. The purpose of the API was to provide a way to build custom communications applications on a single Asterisk instance. It doesn't care if there's multiple Asterisk instances. That's up to you to go do it. So when you start looking at this problem, pretty much the first thing you need right after actually committing to using ARI, you need something that abstracts away the fact that you're talking to multiple Asterisk instances. A number of members of the community have started a couple different projects around this concept. I think Leif Madsen and Bradley Watkins have started a project on GitHub using Go that actually provides a message bus on top of this that abstracts away the fact that you may have n Asterisk instances, all with different channels sitting in different instances. But you'll need something like that pretty quickly. This is a really terrible example of what you shouldn't do, but this is sort of getting the point across. Rather than when my channel enters into stasis, rather than treating that as entering into a conference, I can instead go try to figure out which application I'm supposed to go run on that channel based on where they arrived, based on their extension that they came in on. Go look up, grab in this particular case, hey, if it's 1000, then execute the conference. If it's not, go do something else. And then go execute that particular application. So what you end up with is a picture that looks more like this. Rather than having your Asterisk instances managing everything, your Asterisk instances now are they're not PBXs, and you can have any number of them that you want. And you use ARI in order to actually pull all the application logic out and have application servers that are actually managing the applications themselves outside of Asterisk. And the reason why this is nice, other than simply we can actually scale out Asterisk a bit more, is that you can treat both of these things as scalable microservices. Because if you haven't heard that term enough today, then I'm going to go hammer it as well. When you pull the application logic out, you can find out what your actual bottlenecks are and scale them appropriately. Right. So if the bottleneck is not Asterisk, but how much processing your applications are doing, which sometimes actually is the case, then go add more app servers to the mix. If the bottleneck is Asterisk and you need more raw media processing capabilities, go spin up more Asterisk servers. But decoupling these two things lets you go spend your resources where you actually need them. So wrapping it up, when we've actually done some prototyping with this approach. So this is not just a theoretical set of slides. One of the things, there's a lot of devil in the details with this that I'm hand waving my way through. Certainly, what happens when a call still ends up at the wrong place and you have to redirect them over to another application server, and there's some other things like that happen. But when we've been looking at this and deploying systems like this, you want to keep each individual thing as simple as possible, but no simpler. So Asterisk, if you're trying to actually manage Asterisk, make it manage the media. Make it do the actual media application services, because it's really good at that. But try to keep the actual business logic outside of it and pull that off to something else. Kamailio, make it manage the SIP stuff. It's fantastic at it, right? So go use that and go pull the SIP stuff out of Asterisk as much as possible as well. But the great thing about it is that when this last bullet point is not for nothing. We're all communications developers in the room. But there is a world of other application developers out there that ideally you'd like to take advantage of when you're building your systems and custom communications applications. There's a lot of really smart developers out there who happen to work in Node.js. And doing this lets you make use of them for these kinds of problems, and they don't have to necessarily learn every single archaic aspect of Asterisk in order to get there. If you can present a nice, consistent model of the world, which ARI does, then they have to learn that model, and most of them are very used to learning a REST API, and suddenly, you can take advantage of them to go build custom communications applications as well. And you can move much faster when you can pull the application logic outside of Asterisk. And that's it.
Okay, I saw a question from the back.
Plus.
Hello. Question. I understand WebSocket is the transport for the initial requests and all the core request verbs as well, not just for events?
We've thought about it. It doesn't today, no.
Okay.
Yeah.
So that leads to this kind of curious, I'm sure you've gotten this question before. If you initiate the request via HTTP, why WebSocket as opposed to conventional TCP connection for listening to events? Is there an implied presumption that ARI is going to be driven by web-oriented technologies or primarily used by in-browser applications or something like that?
A few different reasons, none of which are, you could certainly argue for a TCP connection at any point in time. Okay, so there's no complete technical reason why you could not use just a straight TCP connection for the events. One of the reasons is because when you actually establish the WebSocket and you register, that's an HTTP request that establishes the WebSocket. And so the actual act of saying registering your application and saying I'm going to register my conference and own it and receive the events for it is an HTTP request that gets upgraded to a WebSocket that comes back. So that does keep it rather in line with the rest of the RESTful stuff that's going on there. Honestly, we picked WebSockets because it was already an Asterisk. We've actually talked about using other transports as well for the events. It's a very loose coupling between WebSocket as a transport for the events and the actual JSON events themselves. I will say that in the testing that we've done, the overhead of the WebSocket is relatively small and doesn't even show up from a performance standpoint that we've seen so far. That doesn't mean that you can't build a system that proves me wrong, but at the same time, it hasn't been an issue at this point.
I would like to add just about more technical on WebSocket. A good part that they did it is framing. Mm-hmm. So practically you don't have a very complex parsing state. I don't know how much will help when you have like safe communication because you expect this ARI to come from someone that you somehow trust. But like we have it in Kamailio for the TCP and TLS where you can expect a lot of garbage. Practically reading the C packet is very easy if it's well formatted, but if it's someone sending crap, detecting that it's crap, when it's ending and so on, it's really a nightmare. Having framing, I think, helps because you know, okay, this is the packet, I cannot parse it, I drop it.
It makes the client libraries much easier to write, I mean, yeah. For certain.
More questions? Questions, more? Asterisk media server on latest version. For
here. Okay. Ask questions.
From my side, then it's about this new layer you probably presented with a bit more API driven. How you got the feedback from the old let's say telecoms seniors and so on? Because I'm thinking from my perspective, when we started, we didn't went from like being a telephony engine with a number as a main identifier, and there are issues with, most of you are familiar with Kamailio config file being like a scripting language, and they say, well, I put my prefix to send it to that IP address, and say, well, you have to write a if condition, for that, set an IP and then relay. Well, but that's too complex. So I thinking that the telecom, it's a bit, reticent in evolution.
I haven't gotten much feedback on that concept yet. One of the nice things about ARI, and this is kind of just, we spent a lot of time, so when I showed that graph of, you've got the Asterisk world and the ARI world, a not inconsequential amount of development went into providing a safe boundary between the two and being very careful about having the information and how it gets handed back and forth between the two. Some very complex code in Asterisk that does that, because it's actually very non-trivial. One of the nice things about that, though, is that you can kind of jump. My slides advocated, and I even said this is an extreme example of this. It's a very all or nothing jump, right, into ARI. Like, kill the dial plan, replace it with this, right? And there's benefits to doing that. There are drawbacks, right? So, for one thing, anytime you pull dial plan logic outside of Asterisk, you better make sure that the calls that are ending up on your Asterisk instance, you wanted them there. Because now your external system is actually doing the pattern matching, and that's not good. So this is one of those things that you really want to make sure that you understand what you're jumping into. But you don't have to use ARI like that. You can use ARI to replace a single dial plan application and keep all of the traditional telecom, number pattern matching kinds of things. And so it's sort of how far do you want to go into this sort of concept.
Okay.
Okay, we have a queue here. I'm first. Many of us here use Asterisk in production, and we're pretty strict about what we do and when we change stuff. The release policy have changed a bit as well. Can you mention what's changed? Because you're going to change stuff in releases now.
We already are. So yeah, last year at AstroCon, there was a long discussion at the DevCon, and then there was more discussions out on the mailing list, but most of the discussion on the mailing list was, that sounds like a good idea. The release policy Asterisk used to have was that no new features went into release branches once they were made. And that was not a bad idea at the time, because we didn't have the test suite that we have now, and we lived in a different world, quite frankly, at that time. As Ule was even saying, that was, 2002 is a long time ago. But we have a test suite that runs nightly that runs about 800 or 900 tests on Asterisk every night. And so we have very good test coverage of Asterisk, and this is why we're able to go make major changes in the project and go do big things, is because we find out when we break stuff. Not everything, but we find out some of the things anyways. So what we decided is that in release branches going forward, we would allow new features and improvements to be made in any release branch in Asterisk at any point in time. The only caveat is that if you're going to make a new feature in a release branch, you have to have tests. You have to have automated tests, because that's what helps everybody in the community make sure that they don't break the new code that you just added. And that's a fairly reasonable expectation, I think. So has let us actually add some new features into 13 already, which has been pretty cool.
I'm curious about the plans for WebRTC and video together in the future.
They work. I mean, what in specifically?
Video when multi-party is involved.
I don't have any plans for that. That doesn't mean that somebody else wouldn't. I think that it's a awesome concept clearly, as Jitsi Video Bridge shows, it's really cool. At the same time, myself personally, I don't have any plans to go spend any time on that. But Asterisk is an open source project, and so if somebody really wants to go do it, I think it would be awesome. One of the main things in Asterisk 13 is a new bridging framework that makes the bridging technologies a pluggable module. It's a loadable dynamic module. What's even cooler about it is that once you write a mixing technology of a particular type, Asterisk will automatically pick it based on the priority and the constraints that you've placed on it. So nobody has to go update anything. If somebody shows up with a new way of mixing media and the module gets included, it'll just start getting used. So if somebody comes up with a wrapper around Jitsi Video Bridge, that's one actually thing that was proposed that I actually think would be the right way to go do something like that. I don't want to go reproduce what Emil spent 10 years working on. I just want to go use it. If you had something like that, it would say, oh, hey, that's a higher priority than Bridge Softmix, which is the current conferencing mixing technology, and I'll go use that instead.
I can add a bit to that. The reason why we haven't done much of video handling in Asterisk was licensing. But the cool thing now for all you developers is that thanks to Cisco, there is an H.264 library we could use in Asterisk. So we can finally start building applications where we merge text into IVRs in the videos, where we mix videos and stuff. But previously we couldn't. There has been some outside of the project work that we couldn't touch because of patents and licensing and what have you. But the whole world changed because Cisco actually gave away a license and paid the fees. And I verified that with Cisco, so they... Yeah. But, okay, consult your lawyers, but potentially there are new opportunities. The Jitsi Video Bridge just forwards video, not mixes it. Okay, we have a question here.
Unfortunately, I missed last year's AstroCon.
What's the...
Yes, the infinite question about a codec Opus. Consult your lawyers. I'm serious. The last time I handed it off to the legal team. So there you go.
Okay, I'm not employed by an American company. There
you may be
are
luckier.
patches managed by the community, and we need help managing them and testing them. They're all for a fixed mode of Opus, but we need to make sure that they're made available, and if you can help us push them into Debian and other distribution as an add-on, I'll be very, very happy. But it's right now a community thing, not something that I think can be done by Digium unless we convince a lot of the legal people to do the right thing. So that's where it is. We have to fix that. It's an open source project. We have the power to fix it. So let's maintain it, buy beer for the people who keep maintaining it, and work with it.
Okay, so looks like a good suggestion next year to have Matthew also before the break, so we don't need to order another break next year. Questions?
I ended at 3:30.
More questions? Or if not, probably we'll get more updates for those that plan to attend Astricon. I will be there in
please do.
autumn.
One last little plug for Astricon, I guess. If you don't follow too closely along with Asterisk development, which I understand since the mailing list is chatty and everybody's got a million mailing lists, we actually decided to delay Asterisk 14 for a little bit while we still, as a community, wrestle through some of the things that we would like to go do. So things like Uli mentioning the RTP stack and things that he would like to go do. There's still a lot of things on the table. So if you are interested in Asterisk and there are things that you're interested in contributing or participating in, now is actually a good time still to participate in that. What? Sometime in October? There you go.
I would like to say a big thank you to Matt for that decision, because I've been annoyed by releasing by marketing department for a few years. Open source needs to release when we're ready, not when it suits the marketing department. So I think this is an important marker. I'm sad that we didn't make the goal, but...
It was a communal decision.
But a good one for the community this time.
Yep.
Okay, so time for break. I have seen some nice cookies. That means when you cross that door, you agree to the cookie policies of the environment here in European Union.